let's go ahead and jump right into it right now. Oops. Okay, close that out. Alright, today's fair weather here. Well, this is for day 2. Let's go ahead and talk about day 1, obviously, which is today. Today's severe weather here across the upper Midwest, including the 10% hatch and 5% hatch, all the way down to northern Missouri, eastern and central eastern Iowa, northwest and northern Illinois, most of Wisconsin, and eastern and southeast extreme portions of Minnesota. We have the 10% tornado risk hatch. We also have the 30% wind risk hatch as well, extending all across portions of central northern Illinois, eastern Iowa, most of Wisconsin. And you also have the 10%, the 10 to 15% and 30% hatch across portions of eastern Iowa into northern Missouri for hail. And this is where your corridor of likely isolated supercells are going to develop for most part on the current trend. And we're thinking about actually blasting west and going towards portions of central southern Iowa, towards maybe Ottawa or Kirksville area, kind of just waiting for development to happen, just based on the current data currently feeding in right now. Just watching where the severe weather is actually be happening, because a lot of the models right now are showing that supercells develop behind the first initial wave of storms that do develop, and the outflow boundary does sag back like this, and outflow boundary sags back like this and interacts with this environment, kind of a little bit more, a little bit of wind shear, a little bit more turn, a little bit more pulling at the surface winds. You kind of get a corridor of isolated supercells develop right across that area and kind of move off to the east like this. And a couple of the models do pick up on it, and they also pick up that the storms do not develop at 18Z, and some of the models have initial supercells across this whole entire corridor here, and then move off to the east as well. So we kind of got to figure out what we're doing here. Kind of get on the road here pretty soon and get out to the west, and then kind of just go from there to figure out, okay, what's going on, where we're targeting, and this and that. But this is, the main hell risk, but this is where the main line of supercells are going to develop. So we're going to go ahead and look at the model overlap here. Let's go over here, go to settings, and we'll go to what was I gonna do? Alerts. I don't think I have it on here. Okay. I was gonna do the data overlap with but it doesn't look like I have it. Okay, that's fine. Let's go ahead and go up to the HER here. We'll go out to the latest run. That's 10Z. So it has this first initial wave that comes out of northern Missouri and kind of pushes east. So this could be like a Bowen line of storms here. So you got your first initial wave, develops like this. And that's around 3 to 4 p.m. And you're going to have some Bowen line storms, maybe some QLCS tornado threat with that associated. You gotta watch out how this develops, right? But the HER model also has behind us that this outflow boundary swings back like this, and then you get this initial wave here of supercells behind the first wave like this. And this will be probably your main tornado threat behind that, because depending on how this first wave develops, your first wave here, and then your second wave here. Depending on how your first wave develops here will determine how that tornado threat evolves for central northern Illinois, because one, the boundary is going to stall and cause trend and storms to develop across northern Missouri or wherever it does set up, so you'll have torrential rainfall and the risk for significant flooding wherever that boundary does set up at. And then you have the storms are going to be pushing off to the east. This initial wave here will have a Bowen line of storms with QLCS tornadoes and winds gusting up to maybe potentially 75 miles an hour. The tornado threat will have the strong tornado threat with these storms associated with the boundary of southerly winds here across northern Missouri and southern Iowa. And depending on how that first initial wave develops, you could have it extend all the way up into northern and northeast Iowa as well for the tornado threat today. You're still going to have a tornado threat overall across the entire area, but your main tornado threat is going to be wherever that outflow boundary extends and sags back west behind the first initial wave of storms if they do happen, because it is going to cool off the environment a little bit. At least some cloud cover, and once that cloud cover fades away pretty quick, and then we'll kind of look at where that stuff develops later on today. Go to a different model here. Here's the RFS. What was I looking at here? Okay, here we go. So here's the RFS currently. With the latest run, 9Z. So RFS around 1 p.m. shows initial wave of cells here developing. And then behind it, it has, boom, outflow boundary, big time tornadic supercells developing. So yeah, initial wave here, the storm's developing. And they take off. And then you get tornadic supercells developing behind that. So you can see here's this outflow of the initial wave, and we can see where that boundary does sag back at. The boundary on. So the boundary does sag back just like that. This is what the RFS is showing. So outflows like this, and then the boundary sags back like this. Or we're all wrong, and no, there's the boundary. So that's where it's clearing up at. On the theta E, it says the boundary sags back like this. And that's right here. Second wave of supercells will be just south of that boundary. You get some southeasterly wind scheme pulled along that boundary. And then there's tornado potential there. I get a sounding right there along that boundary. Should be decently photographed. And there you go. LCL's around 300 meters. So southeast Iowa, northern northeast Missouri, I'm thinking that's where the main tornado threat's going to be today, possibly. It's going to be wherever that outflow boundary sets up. It's going to keep some of those surface winds turning to the southeasterly or southerly surface wind, because most of your winds today across the area seem to be veered southwesterlies for the most part, unless wherever that boundary sets up, the outflow boundary that sags back with the first initial wave that comes through, that's behind that. It's going to be where the tornado threat sets up behind that first wave. And that's what the models are really picking up on at this point. See, the NAMNES has it a little bit more. Oh no, NAMNES has it where it needs to be. Okay. Over here, reflectivity. It's like two initial waves, showing two initial waves of lines, obviously. See what the wrap. What the wrap is showing. Where is the wrap? Try to see what method I use. Yeah, it mostly keeps it to the south as well. Might have to go west today, because yeah, this is interesting how this is setting up. Of Kansas City coming this way, which would be possibly the first initial wave to connect tracks like this. So let's see here. Yeah, see that's 364 miles away. 364 miles away right there. So it's like the first spin. You got first spin like an MCV kind of flow there. You can see that there's spin definitely behind it, right? You get some north to south, and then ahead of it you have south to north. So a little bit of spin there. It's elongated, but you can see that this could be possibly the first MCV or MCS develops with the line, the first initial wave, right? So maybe some tornado threat with it, but it'll be the late morning, early afternoon that moves out. So it's already developing here out of this Kansas City area, and I'm thinking it's going to extend down. There's some cumulus here developing with that underneath that high level cloud cover. Her model picks up on it right there. What's the echo toss with it? I'll already get some slight tops with it. Only reaching about 30,000 in some areas. 30,000 to 40,000. You can see how you got some spin there. Kind of going like this. And that's kind of feeding like this. Like it's a little slightly elongated here. So a little bit of an MCS maybe. And that kind of points this way is what the models were picking up on. So late morning hours, early afternoon hours, there's your development of the first, I would say, line that's going to develop and push to the east later. It looks like it's coming fairly quick. Since you guys are all hyped about tomorrow, we'll talk about tomorrow here in a second. I'm just kind of currently watching what this data is doing here with this. Alright, let's look at tomorrow. Let's see here. We'll go down to 06, flop into tomorrow. Tomorrow obviously looks like some big time supercell movers here across parts of the central southern Wisconsin and northeast Missouri, northeast Iowa. And look, all these showers and storms here are all rotating. They all got beams to them, right? There's your tornado perimeters across that area. Yeah. Big time tornado air mass there across portions of south central Wisconsin and northeast Iowa. So yes, tomorrow obviously is the bigger day out of today. Yes, tomorrow is obviously the bigger day. Thursday definitely has a lot of potential on the table. Look at the 0 to 3 kilometer cape here, maxing out across the entire environment. Your cape here with the photographs here, very largely curved. Talking about a very destructive tornadic day for the most part. I promise you, tomorrow could possibly go moderate risk for not only winds but tornadoes too, depending on how the scenario develops. Your 850 millibar jet here. 62 knots picking up on her there. Look, your 700 here, 65 knots. And your 500 millibar streak here at 60 knots too as well. So, yeah. Looks very destructive. And those storms definitely push off to the east. But, your better tornado potentials will be up there with those southerly, southeasterly surface winds all the way up there closest to those storms on Wednesday. See, those areas would definitely have be some rotating beams. And that goes after the first initial wave too. See, there's an outflow boundary right in there with the 70 dew points. Your main warm front's set here, and that kind of sags back north behind the first initial wave. That boundary lifts north, and that's where you get your main tornado potential along that boundary. Same thing like today. Boundary lifts north. It's doing the same thing tomorrow, but more significant with the jet stream overlap. And in today's the same scenario as well, where the first initial wave sets the stage with the outflow boundary, and then that boundary lifts north behind it. The same thing today is what that is doing tomorrow. So just the only thing about today is I figure out where that boundary sets back. And I'm thinking it's going to be somewhere across central southern Iowa. So probably have to get down here into southern Iowa and just wait to see how this does develop. And just patiently wait. That's the game today. because it's definitely not going to be up here. It's going to be north-south. Because here that comes now. See, behind that you got a secondary low, so you got like some sort of MCV or something here. You got the secondary main low up back here spinning, or it's somewhere a little bit more further north, but it's somewhere over here, because you got your dry line, somewhat dry line here, warm front, way up north, and this is pushing east. First initial wave, and then right directly behind that is going to be your initiation. That's all pushing off to the east. And you got some cumulus here to the deep south. And that's going to push into this northern Missouri, southern Iowa environment later on today. So I'm thinking southern Iowa, northern Missouri today's to play. Other than that, stay tuned for later updates. I'll go from there.